Well, hello, welcome to Yosemite National Park. I'm a park ranger here. My name is Phaedra Stefanakis. And today we're going to talk about glaciers. But we can't talk about glaciers without talking about how Yosemite came to be. It all started a long time ago, millions and millions of years ago. Somewhere around 130 million years ago, the North American plate and the oceanic plate collided. Oceanic plate, being much more dense, started to subduct down. That subduction, which means it goes down under, starts to push up the North American plate. When we step on a rug, for instance, when we step on it, it gets that first wrinkle. Basically, that's what the entire Sierra Nevada range is, that first wrinkle in a rug when you step on it and it creases up. Well, all of this entire range of Sierra Nevada were volcanoes. Volcanoes had lots of lava spewing about. The magma underneath, which is basically lava underground, is considered magma. And that magma is producing lava and spewing, and it's nothing like what we see today. But just like all things, they start to die off. As they die off, that magma underneath starts to cool. Well, now we have all of these old volcanoes and this magma underneath. Well, once again, over millions of years, that first string of volcanoes start to erode away. Erosion due to wind, water, time, all of these things makes the mountain range start to wither away into rolling hills. Well, eventually that magma that was underneath, that is now cooled and solidified, which means that it's hardened, are now being exposed. But they're not the big mountains that we see here today in Sierra Nevada. Nope, those were rolling hills. And over more time, it started to continue to uplift. So with the subduction and the constant uplift, there was rivers and streams that first started to slowly create the valleys that we see today. And those just meander around, creating S-turns and just producing little rivers and streams, little valleys. When a river and stream create a valley, those are what we call V-shaped valleys. So these V-shaped valleys that are created by rivers and streams, eventually, as the mountains continue to grow, it means that they start to move faster and faster. And with that increase of pace of water flowing means that they can erode that much quicker. And that erosion starts to create deeper and deeper canyons. Well, approximately 2 million years ago, we had our first period of cooling, which we call a period of glaciation. Those rivers and streams, still being uplifted as they are today, slowly started to fill up with snow. Approximately 100 feet of snow or more creates a glacier. Well, a glacier just isn't called a glacier because it's a big sheet of ice. It has to be moving. And these glaciers started far up into the mountains, high up, where gravity can slowly pull them down, allowing them to move. Well, with the big accumulation of snow that we have, it starts to get really slick down at the bottom, allowing the glacier to glide over, sometimes creating abrasions. And also with the more and more glacier that we have, the bigger it is, it means that it can pluck rocks right off the side. Things start to fall on top of it and slowly starts to continue to move down the valley where these rivers and streams once were, slowly eroding things away, taking them off of the mountain hills and sides. Eventually, there's a pile, an accumulation of rocks and all sorts of debris that have fallen onto the glacier, as well as the glacier plucking it away. What happens that, down along the sides of the glacier and down at the very bottom, it's where most of the accumulation has occurred. When the glacier starts to retreat, it drops everything right where it stands. Because the glaciers no longer can move, water can't move these enormous boulders that were left behind, so they just drop. Those are ways that we can find out today that there were glaciers in the area. Those are called erratics. And those erratics you can tell by when you look at an area, it's really flat, but all of a sudden there's this huge boulder that doesn't look like anything else around it. That's how we know that those are erratics. Other ways that we can find out whether or not a glacier has come through the area mostly is the shape that the glacier created. Those once upon a time V shapes, if you try to shove ice through a V, that doesn't necessarily work. That ice is too thick. and it wants to make sure that it can fit through. So it starts to bulldoze its way through, making more of a U shape. That is the #1 way that we can find out if a glacier has been in the area, is a U-shaped valley. So when the glacier started to recede, the last period of glaciation that we had was around 10 to 20,000 years ago here in the Yosemite vicinity. Well, when those start to recede, the glaciers drop all of those debris that have accumulated on it, and that is called a terminal moraine, the very end of it. That's how we know about how far the glacier went down. And that is an accumulation of a bunch of boulders. And what happens is that you'll see a very flat area, big bump, followed by continuous flat areas. And so we can go in and we can check out those rocks to see about how long they've been there. But that's an example of a terminal moraine, which also acts as a natural dam. So as that ice starts to recede back, it creates more of a lake down at the bottom. So Yosemite Valley actually used to be a lake once upon a time. But after lots and lots of time, remember thousands of years at this point in time, sediment has slowly filled in the valley and the water has dissipated. Parts of the terminal moraine are still visible here in the valley today, although most of it has been washed out, or pioneers, when they started coming here into the park, they blew up parts of it, allowing for the water to continue along so people could reside in this area. Glaciers are very important for all of us, all around the world, not just here in Yosemite in this vicinity. The reason is because glaciers hold natural, fresh water. And it's also a very good way to keep this area cool, not just Yosemite, but once again, over the entire world. But as we continue to have a warming effect due to carbon monoxide, the ozone slowly being depleted, this world is getting warmer and warmer. And so with that, it means that we have less glaciers. They're receding quicker than they used to. And also what happens is that as they get smaller and smaller, more debris falls down on them, and they start to get dirty looking. Well, most of us think about, well, it's just a dirty glacier. That has no problem. What happens is that when a glacier becomes dirty looking, it means that a lot of dark stuff is falling onto it. That dark stuff on top of the glacier absorbs the sun. Just like when you wear a black t-shirt on a hot sunny day, you're more warm than if somebody was to be wearing a white or cream colored shirt. That lighter color reflects the sun, whereas the dark shirt absorbs the sun. That's what's going on with our glaciers today, is that they're attracting the sun, and that means that they melt that much quicker, depositing all of that fresh water into the ocean, where they're no longer usable. It has less space for the animals that need glaciers in order to exist, for example, polar bears and penguins. And so those glaciers are becoming smaller and smaller. This is a concern for us, as it should be. But whether or not we are in a period of warming and will eventually become to a period of cooling, one never knows.